Hey, hello guys. Welcome to Network Beat. So this is Tanguturai. So in last video, I have shown you how to configure eBGP pairing between R2 and R5. So and also I have stated that uh, we may face some issues like in AS500 because when we have tried configuring iBGP between R2 and R6, we haven't configured any BGP protocol on R1 and R7, right? So here we haven't configured any BGP protocol on R1 and R7. So what type of issues that we can come into, right? So the problem that we can face is like the reachability issues. So let me explain that in this video. Let's say that R4 is having this many number of servers and it is trying to advertise its prefixes, right? And for time being you don't consider this direct link between R3 and R4, and we are trying to ping R4 from R5, right? Even R5 is connected to a few of the servers. It is trying to advertise its prefixes. We are going to verify whether R4 able to reach R5 and R5 able to reach R4, and we'll try to do this lab and we'll figure out what are the issues that we will be facing when we are not running a BGP in R1 and R7. So just to recap, I'll just tell you what it is there for the time being. So here for time being, this eBGP pair is up, right? And what else? And in R1 here I have configured eIGRP 100 for IGP protocol, and then I have a iBGP configured between R2 and R6, where I did not configure any BGP on R1 and R7, and there is again an eBGP pairing done between R4 and R6. Okay, so here we'll go and verify that. Let's verify R2 and R5. So let's go to R2 and show IP BGP summary. Here, yes, I can see a neighbor with from R2 it is. I have peer with RR and also I have peering with R5. Let's go to R5. Show IP BGP summary. I have peering with R2, right? So let's go to R6 and verify. Show IP BGP summary. I have pairing with iBGP pairing with R2 and eBGP pairing with R4, right? Great. And let's go to R4. Show IP BGP summary. I have pairing with R6, which is eBGP, and currently it is not receiving any prefixes. And also just make a note, in R5 also we are not going to receive any prefixes as of now. If you go to R6 and see, there is a prefix is received from R2 and also a prefix received from R4. So in R2 also it is receiving one prefix from R6 and one prefix is receiving from R5. So what are they? Let's go and verify that in the BGP table. What is the command to verify? Show IP BGP. Here from R2 I'm seeing two routes. One is coming from R4, which is 4.4.4.4, which is a valid and which is learned through iBGP peer. Great. So here 5.5.5.5, which is learned from R5, which is valid and best path, right? Great. So here my question is, why this is not a best prefix? Okay, what does it mean? Okay, so BGP table, whichever the prefixes are learning via BGP, everything will be there. That means like the best path, non-best path. That means the routes, prefixes with best path, non-best path, everything. All the prefixes will be there. If you go to routing table, show IP route BGP, here only the best path will be there in the routing table, correct? So that is what the thing is, difference between show IP BGP and show IP route BGP. Whichever the best path, only it will be there in the routing table, but in BGP we'll be having the best path, non-best path, everything will be there. Now for some reason this 4.4.4 is not a best prefix to get it installed in the routing table. Sorry, not a routing table, it is a forwarding table. So here, why? What is the reason behind this? Let's see that from R2, I'm receiving this prefix, and here it states my next stop is 46004. This 46004 is somewhere configured on this interface. So R2 does not have any idea how to reach this particular prefix configured on this interface, right? Because R2 does not have any visibility. It did not, that 46 network was not advertised anywhere. If you go to show IP route and see, I do not see any 46 over here, right? Or just you can give show IP route 46.0.0.0. See, there is no network in the routing table. So that is the issue, because the next hop is invalid. R2 doesn't know how to reach this next hop. So that is why R2 is not installing this prefix in its routing table. So what we have to do in this scenario? In BGP, you guys have to understand, okay, whenever a prefix is advertised from R4 to R6, all right, it is advertising 4.4.4.4 to R6 with a next hop 46.0.0.4, right? When R6 is going to advertise this particular route update to its iBGP peer R2, it is not going to change the next hop attribute. Okay, that means R6 received the next hop attribute as what? 46.0.0.4, right? This next hop attribute will not be changed when R6 is updating to R2. So here what we have to do, whenever the R6 is updating to R2, R6 should change this next hop attribute as its own IP address, so that R2 can reach the prefixes whichever he is advertising, since R2 does not know how to reach 46.0.0.4. Okay, how we can do that in the configuration? So let's go to our terminal. So in R6, okay, in R6, okay, what I have to do, configure terminal router BGP 500, right? No, my neighbor is 2.2.2.2, and I have to just say next hop self. That means whenever whenever R6 is updating anything to router 2, it is going to make himself as a next hop for any prefixes, okay? Because if you go to R2, now you can see that in show IP BGP, sorry, show IP BGP for 4.4.4, it is advertised by R6. It didn't change the next hop attribute. That is why it is not valid. Once I issue this command, okay, and let me go to R2 and let me clear the BGP, clear IP BGP star soft. I just explain what is this clear IP BGP. I'm just resetting my BGP connection without any like in soft manner, not the hard manner. So I just explain what is the difference between that. So let's see now, show IP BGP. Did you notice now this become valid and best, and the next stop attribute is changed now from 46004 to 6.6.6, right? So previously R5 was not in R5 BGP table, it was saying only 5.5.5, which is its own IP address, right? How I am saying, whenever you see the next stop is 0.0.0, that means this particular prefix is locally present with R5, okay, or within that same AS. So here, what I'm here, if you go to R2, right? Okay, just remember, whenever you are seeing the next of 0.0.0, that means this particular prefix is locally present with R5. That means there is no next stop because it is associated with R5 only. That is why the next stop is 0.0.0.0. So now if I now previously again R2, because of next stop invalid, this particular route was not installed in the routing table, so that is why this prefix was not advertised to R5, right? Since the next stop is not valid, R2 didn't consider this the best path or the good prefix to get it installed in the routing table. This was not advertised to R5, but now R2 is seeing 4.4.4 as a best prefix. So this will get installed in its own routing table. Show IP route BGP we see previously this was not there. Now we can see 4.4.4 in our routing table. Now this will be advertised to R5. Let's go and verify that. Show IP BGP. Right now 4 is installed in R5. That's great. But if you go to R4 and just give show IP BGP, still R4 is not receiving the fine network, okay, which R5 is advertising, because the same issue what we faced with R2 we have to do similarly for R6. So let's go to R6 and do the same. So here router BGP 500 and in R2 configure and router BGP 500 for my neighbor 6.6.6, whichever the update I am giving, make the next stop as self, as R2 itself. Once I do this, okay, let me go to R6 and show IP BGP. Okay, let me clear the process, start soft, and let me issue show IP BGP again. Previously it was not the best prefix because the next stop was 25005. R6 doesn't know how to reach that 25005. After the configuration in R2 and after clearing the BGP process, now R6 is receiving the new update from R2. See, the next stop is changed from 25005 to 2.2.2.2. Now we can see show IP.BGP. Now 5.5.5 is getting installed in the routing table. Since it is a best path and it got installed in the routing table, there is no issue for R6 to get it advertised to R4, right? So let's go to R4 and check whether he is receiving that prefix. Show IP BGP. Yes, now he is receiving because R6 is advertised. It is a best and valid prefix, so obviously it will be there in the routing table as well, right? Show IP route, if you just want to filter only the BGP routes. So R4 is receiving the PHY network. Great. Now R4 is seeing the prefix 5.5.5 and R5 is seeing the prefix show IP route BGP 4.4.4, right? So that means they are receiving the destination prefixes, so there won't be any issue now in the reaching the destination, right? So that is what not so this is not going to happen because there is an issue still present in our setup. Let's try pinging before fixing those issues. In R5, let me try pinging 4.4.4.4. Okay, so what does it mean? When I ping 4.4.4 from R5, Okay, whether R4 is going to say anything. Debug IP ICMP. Let me enable this just to capture if any ICMP packet is hitting R4. Okay, and let me reinitiate the ping response from R5. There is no packets coming to R5. We have the routes, right? But it is not going to receive anything at R4 because the problem is not with R4 or R5 or either R2 or R6. The problem is now with R1 and R7. Okay, R2, now when R5 is trying to initiate a ping, okay, it has to go to R2, and from R2 it has to either go via R1 or R7. So let me go and enable debug IP ICMP on these two routers, R1 and R7, and let's see what happens. Okay, let me go to R1 and R7 debug IP ICMP, and also let me enable debug IP ICMP. Okay, let me initiate the ping again from R5. So when I'm trying to ping 4.4.4, okay, now okay, it is going R5. Okay, fine. See here, the destination is 4.4.4, host unreachable. Okay, that means R7 is saying I don't know how to reach 4.4.4. Okay, this message is sent back to 25005. That means what does it say? Your source IP address is 25005, correct? 25005 is configured on this interface. You see 25000, here is .5 and here is .2. So when you initiate just a ping on the destination prefix, your exit interface IP address will be going to consider it as a source IP address. Now the question is, does R4 know how to reach 25005? That means 2500/24. Because R4 does not have any idea about 25 network. If you go to R4 and see show IP route, no, there is no route for 25 network at all. It only know about 5.5.5.5. So what I can do, instead of ping 4.4.4, I can initiate the ping 4.4.4 from my source loopback 0, which is nothing but 5.5.5.5. Let's see R4, that means R7. As again, I'm seeing the same message, destination 4.4.4 is not reachable. Okay, that means there is not something problem with R5, R2, R6 or R4. There is problem with R1 and R7 because R1 and R7 are running eBGP. They don't have any idea about the BGP protocol because we haven't enabled BGP on R1 and R7. So whatever the prefixes are learning or exchanging via BGP, there is no visibility for R1 and R7. So since the routing has to go through R1 or R7, obviously they have to understand what is the network and how they want to route that. Those information, obviously they have to get that. For example, now basically in routing, what happens when I'm trying to ping 4.4.4.4 here, right? R5 has a route. Okay, that means let's go to R5 back. I am just explaining in deep. If you guys get bored, I'm sorry for that, because I know there are lots of basic things people are finding hard to understand. So I'm just trying to explain in detail. So let's see whether I have a route for 4.4.4. Yes, I have the route which is learning via BGP. So my next stop is 25002. That means my router 2. So my packets will come here. Now the question is whether router 2 has a route for 4.4.4. Let's go to R2, show IP route 4.4.4.4. So router 2 also having a route of 4.4.4 which is through router 6. Awesome, right? That means it has a route. So now the question is router 2's next hop is R6, right? But remember, this is a logical iBGP pair that we have made between R2 and R6 since there is no direct connection, right? Though how R2 is going to reach R6 either via R1 or R7, isn't it? So now my question is, right, when R2 is going to forward that packet, okay, even though the next stop is R6, R1 or R7 should know what is the destination because he is going to route the packets based on the destination IP, not based on the source IP. So I'm trying to ping 4.4.4 from R5. So my destination is 4.4.4. So does R1 or R7 have routes to 4.4.4? Let's go and check that. R7, obviously he don't have, that is why the ICMP says that host unreachable. Show IP route 4.4.4.4. There is no network in the routing table. Same for R1 as well. So when there is no route, obviously R1 and R7 is not going to forward that packet to R6, even though R6 have the route to R4. Now this is the problem in the transit which is happening because of the lack of BGP on R1 and R7. Now there can be two solutions. What you can do, one, you can enable BGP here, right? And you have so that you have the peering with R6, right? And also you'll be having peering with R2, but this is not going to work without having the configuration of route reflector or configuration. We'll see what is that later. But in our current setup, what we can do is like, now we have to make sure R1 and R7 know about 5.5.5 and 4.4.4 prefixes. So in order to do that, what I can do, I can go and do the manual configuration like IP route 4.4.4, this is your next stop. I can do that, but it is a painful task. Just think in the real time, for each and every prefixes I cannot go and write a static route. So the next solution what I can do is, we are receiving all these prefixes through BGP and R6 is running BGP and eIGRP. Now our objective to make R1 and R7 to know about 5.5.5 network and 4.4.4 network. So R1 and R7 have only eIGRP routing protocol is getting enabled. So now I want to redistribute the routes learning via BGP into eIGRP so that these routes also will be sent to R1 as an external eIGRP external routes, so that R1 and R7 know about 5.5.5 network and 4.4 network and how to reach them, right? Once we do that, then obviously there won't be any issue in the transit because of R1 and R7. R3 and R4 can reach each other. Let's go and verify that. So how to do the redistribution? So let's go to R6. First, I'm just going to make a redistribution on R6. Okay, I'm just going to redistribute on R6. Configure terminal. Go to your router because you are going to get the BGP routes into the eIGRP. So go to your eIGRP, go to eIGRP 100 and just say redistribute BGP, and your BGP autonomous system number is 500 and you have to mention the metric, right? what metric that you have to use. If you give question mark, basically eHRP uses complex metric like bandwidth, delay, load, reliability, right? 5 parameters and MTU. So here, first is bandwidth. So let me give here something 100,000, and after that let me give a delay 0, and let me give the reliability is 255, which is 100% reliable, and the bandwidth also I'm giving 255. It is just is as per wish and based on the requirements that we can tweak these parameters, and MTU for the path I'm giving 1500. Oh, that's it. Okay, let me just copy this. Similarly, now the thing is like R6 has redistributed, right? Now R1 and R7 will know about 4.4. network, but since R1 and R7 will not know about 5.5. network, since we haven't done any redistribution on R2. Once you do the redistribution on R2, then R1 and R7 will know about 5.5.5 as well. We'll go and verify that now in R1. Now show IP route. See here, I'm receiving 4.4.4 but not 5.5.5 yet. Same here. Now show IP route 4.4. Yeah, now it is redistributing via eHRP, correct? Sorry, now I'm learning 4.4.4. Once I do the redistribution on router 2, then these guys will be learning about 5.5.5 as well. Once that is done, then we can ping from R5 to R4. Let's go and do that. Configure terminal, router eHRP 100, and sorry, let me just copy that. Redistribute BGP. That's it. Now let's go to R1. Let's verify. Now I'm receiving 4 as well as 5. Am I right? And in R7 also, let me show IP route eHRP. I'm receiving 4 as well as 5. Now let's go and see whether I'm able to ping 4.4.4.4. Still it is not pinging. Why? Remember guys, again and again I'm saying this, when you issue ping 4.4.4, your source IP address is basically your exit interface. Since any of this router, that means R4 doesn't have any route for 25000 network, right? So he's not going to get that packet first of all. So what you have to do, you have to ping from your loopback 0, which is .5.5.5.5. Then R4 can get that. Source loopback 0, hit enter. Now we are able to reach that, right? So the summary, the conclusion is like, if the AS500 is a ISP network, okay, the redistributing the things is not going to happen easily, because in ISP all these routers will be running BGP, because they are the one who is maintaining the internet routes, prefixes, everything. So each and every router in the ISP is going to run the BGP to maintain the internet routes. So in that case, we cannot go and do in this fashion, right? So instead of this, basically what we'll do, we'll be learning something called route reflector configuration to make the setup work without any redistribution to the IGP protocol. We'll be discussing more about that in our upcoming videos, and thanks for watching. Stay tuned. Bye.